Welcome to Physics 2212 Lab 4, Circuits. The goals of this lab are to predict the behavior of circuits with resistors and capacitors, investigate this behavior using PHYS simulation, and to compare the predicted to actual results. I found that the current in the first circuit is 0.02004 amps. The voltmeter reads -3 volts when the circuit is open, and the sum of all voltage changes is 0 in any circuit, not just that one circuit. My predictions did match the results, and the RC constant of the final circuit was 5.88 seconds. Some important formulas: Ohm's law, I equals V over R. The node rule, the current in is the same as the current out for any node in a circuit. The loop rule, delta V total is 0. The sum of all voltage changes in a circuit is 0, or in any loop in a circuit. For resistors in series, the total resistance is the sum. Total resistance is the sum of the resistances of each individual capacitor, and in parallel, 1 over the total resistance is the sum of 1 over the resistance of each individual capacitor. Capacitance is Q over the voltage change over the capacitor, or E naught times the area of the capacitor's plates over the separation distance. These are the circuits in question. On the left, we have 2 batteries in series, 2 resistors in series, and then we're measuring the current in 2 different locations. In the middle, we just have 1 ammeter, and then we're measuring the voltage drops in a bunch of locations. And then the right circuit we don't actually use, but that is a picture of an RC circuit. Note that the system is either the ammeter or the voltmeter, and the surroundings are the circuits. Part 1, resistors in series. The predicted current was 0.0204 amps. The actual current was 0.02 amps. So those matched up. And reversing the ammeter had no effect for me, although I would assume that I have a setting messed up and it's supposed to show up as negative. The predicted current for the open circuit with 2 resistors in series was 0 amps because the circuit is open. The actual current was 0 amps. The predicted voltage drop over the gap was -3 volts, and the actual voltage change was -3 volts. Part 3, the voltage changes around the circuit. It's 0 everywhere except for across the resistors and across the batteries. And note that these voltage changes do add up to 0, -0.96 plus -2.04 plus 3. And then there's the voltage drop over the course of the circuit. Part 4, the ammeters in parallel. So the current increases because the second ammeter gave a path of less resistance, because in this simulation the resistance of ammeters is 0. It essentially acted like the circuit only had 1 resistor. In real life, this wouldn't have actually been the case because ammeters do have resistance, but in the circuit, it just acted like only the top resistor was there. Part 5, calculating resistance. The resistance of the 47 ohm resistor was 47 ohms, 100 ohm resistor was 100 ohms, and then the resistances of the wire and ammeter were 0. Again, in real life, this wouldn't be the case, but in the simulation, those values were both set to 0. The time constant of the RC circuit, so that's the time for the voltage to drop to 1 over E of the original. So I got this to be 5.88 by measuring the voltage at 5 seconds, 10 seconds, 15 seconds, and 20 seconds, and then finding the slope of the natural log of delta V over delta V naught graph. So what if we used an actual ammeter in these? Like I said, actual ammeters would have resistance, so we would have gotten different results. It would have essentially acted like another resistor. And then what if we used a real battery and no resistor to charge the capacitor? So in the simulation, if we used a battery and no resistor, the capacitor would just charge instantly. In real life, real batteries have internal resistance. So it would still charge the capacitor very fast, but definitely not instantly because the internal resistance of the battery would contribute to the circuit. That was Lab 5. Thank you. Do not transport any item for someone you do not know. If you believe that someone has tampered with your